Hi everyone, my name is Max, and my presentation today will be about a companion tool for CS 7646 machine learning for trading. A bit of background, I took machine learning for trading last semester, and I found that the final project was a bit difficult. It had much stricter performance requirements than the rest of the course, and if your understanding of hyperparameter tuning was shaky, or you chose bad technical indicators for your features, you really had to crunch to get the project done on time. If you were to go look at the course forum in machine learning for trading, you would notice that a lot of people were having the same issues that I did. There were posts going to like the very last day of class, kind of frantic, saying, "Hey, how did you guys resolve this?" So my project was aimed at developing a companion tool so that people could practice hyperparameter tuning and build their understanding earlier in the course. At the start of this semester, my research was focused on computer science education. And what I learned from that is that if you combine visualizations with simulations and hypothesis testing, you can help novice learners to a subject build deep understandings of complex systems. And the reason for that is when people are first learning a subject and they're new to it, visual interactive learning is much more effective. As they become more versed in whatever topic it is, you can move them towards more text-heavy resources, which are actually more helpful when you're more of an expert. But you do have to tailor your content and how you deliver that content to your students' knowledge level. The reason for using simulations would be that they allow you to test and refine, like I mentioned before, your understanding of a complex system. So when you intentionally hypothesis test, thinking about what your understanding is, your expectation is, and then you test it and you validate if that actually matches your understanding, you build not only your understanding of that particular system, but it helps develop your own metacognitive process. So once you're learning something else, say later in the semester in machine learning for trading or any other class, it helps you learn how to learn. And that process, for simulations at least, is very helpful in a situation where you can't really practice that understanding otherwise. So things like medicine, physics, they also use it because it's very expensive to fail in those. But simulation would be helpful in machine learning for trading because you aren't really testing and validating your understanding of feature selection and hyperparameter tuning until you go into the final project, which is very limited on time. This is what my tool ended up looking like. So some features I wanted to include had to be dropped because I miscalculated what would take the most time, but the core components are all here. So the homepage explains some background from my experience, and then gives them some pointers here about the class, explains how to perform hypothesis testing and that they should do that with this tool. And then it guides them to the main content of the website. And I actually ended up not implementing the Q-learning because of time constraints and because of feedback I received on the first two milestones. But the Q-learning or the decision tree is the main focus of this anyways. So the information on the right-hand side is there to guide the user and suggest some actions that can get the user into a hypothesis testing mindset, right? And on the left side, obviously, we have the actual tool. So going over the right-hand side, we have some instructions for using the tool here, as well as here. And then we give them some some goals, um, some targets to achieve, right? And they're there to guide the user's learning process. That way, it isn't just kind of aimless, seeing what happens kind of deal. And on the left-hand side, we have the actual simulator. So here we can select our hyperparameters with some tooltips to explain exactly what they are. And they're giving valid input ranges, right? And they can, behind a hidden menu, choose their features, which was put there just to kind of reduce clutter, to not have to fit all this on the screen. And if the person coming to this website actually follows the tips and instructions here on the right-hand side, editing the max depth and then editing the max leaf nodes, they would essentially follow a basic hypothesis testing workflow, right? You would hypothesize, what does changing my max depth do? Say I think, hey, if I increase max depth to 3, my tree should actually get longer, right? So this is at 2. And I say, oh, I think it's gonna become bigger because it should hit 3 layers, but it doesn't change, right? And then I have to say, well, why was my expectation wrong? Or I could have said, it's not gonna change because max leaf nodes is still 2 and there's 2 leaf nodes. But then they have to then run it again with the max leaf nodes as suggested on the right-hand side. And they'll see that their tree changes, right? And they would also look at the performance and say, hey, why did my performance actually go down when I increased max depth and I increased max leaf nodes? The goal here is that it's causing the user of the simulation to question why the thing that they expect is or isn't happening. And the other piece we have here, aside from those two visuals, is the feature importance, which is just checking what the most effective split would be. But that would hopefully be useful to students because it tells them in relation to each other, right, which features are most likely to be useful splits. And that's something that in the course, people can't really test themselves. Thank you for watching.